So where does this leave us? Well, we've covered an awful lot in this session. We've hopefully started to understand the mechanisms of ventilatory control and how the changes in VO2, VCO2 and VE and blood lactate are coupled and connected to the changes in exercise intensity, but how when we start to increase intensity, we get to that point of lactate turn point that we lose the uncoupling between ventilation and VO2, because the second source of CO2 is coming in, driving up that ventilation response. We've understood the methodology now for identifying the gas exchange threshold that we need really to follow the work of Gaskell. We need to identify it using V-slope and the ventilatory equivalents. And in the ventilatory equivalents, you need a moving parameter, which is VE VO2, against a non-moving parameter, which will be VE VCO2. And we compare those to the blood lactate response. We've looked at the validity of these. We've identified actually that it does seem to be varied. The physiology does stack up, but there are contrary studies, and I think one of the messages here is look at those contrary studies, and one of the main things you generally find is it's a methodological issue, not a physiological issue. And then finally, we've looked at and identified the respiratory compensation point and recognised that RCP reflects the boundary between heavy and severe exercise. It is the same workload, or should be the same workload, as maximal lactate steady state, and therefore reflects the loss of both respiratory and metabolic control. Therefore, you lose a lactate steady state, you lose a VO2 steady state, and actually beyond VCO2, VO2 will be driven to its maximum value and lactate will be driven to its maximum value.